That's it for me. I think now we can transition to Locke's presentation.
Hi, everybody. I'm Locke. Software control models is a new program that we're starting. And what are software control model? So since 2024, we've been seeing a transition from multi-agent systems to native agent models, which we usually build on a multimodal vision language model base and trained with procedural workflow data and GUI visual question answering, reasoning data, computer use data, for example. So SOTA models like UiTAR's GTA-1 with O3 and OpenAI's computer use agents, they all follow this type of structure, and they were trained to take observations like screenshots and text instructions, and sometimes HTML or DOM tree to represent the states, and then it spits out sometimes plans or reasoning in the form of chain of thoughts and or code or actions that are compatible with many software interfaces, such as on applicational and also OS level. So usually you see actions such as mouse clicks, drag actions, text input, etc. And so where are we at today? Why are software control models important? First of all, software is everywhere, and software interfaces are diverse and multimodal. It's more than just what the current coding models support in text interface. And there are many software environments such as robotic simulation like Gazebo, AirSim, or even design softwares like AutoCAD that would involve both vision and text modalities. And multi-agent systems are very brittle and limited by the underlying learners, as Hirsch mentioned. And of course, everybody wants to build a helpful assistance to automate many software tasks like Java's. Next slide, please. So where are we at today with software control models? There have been many different types of benchmarks, and they can be categorized roughly into offline static benchmark and online simulation-based benchmarks. And then by platforms, you have desktop, mobile, and web benchmarks. And by the targeting capabilities, you have visual grounding or action-based multi-step planning benchmarks. And the two most famous ones are on the left, you can see ScreenSpot-Pro, which focuses more on visual GUI grounding tasks. And on the right, you can see OSWorld, which spins up virtual machine instance to simulate an environment for agents to perform digital tasks. And with today's SOTA, the leading model can only perform 45 can only score 45.2 on OSWorld, and they can only achieve 61.6 on ScreenSpot-Pro. And even then, most of these performances are not very consistent and robust. Next slide, please. So we have seen current challenges for like generalization on unseen components, or visual grounding that has troubles understanding GUI component affordance, especially unseen ones, and also reasoning the visual layout. And in terms of planning, these models have trouble recovering from error states or tracking the overall task progression. And as for what's for us, our software control model program is planning to work on three fronts: eval, data, and model. And specifically, we're going to build systematic and rigorous evaluation frameworks that supports the downstream data curation augmentation pipeline, and therefore to support us to build better and more robust and functional models. And yeah, that's it for software control models.